Thank you. Good afternoon, everyone. So I'm the head for science technology policy at the OECD, Organization for Economic Cooperation and Development. So we are an intergovernmental organization with 38 members and 8 more to come. And we are kind of knowledge hub. So we produce data, analytical reports, and best policy practices, let's say, summarized like that. In our area of science, technology, and innovation, we work on science policy, obviously, on emerging technologies, and so responsible innovation in emerging techs, including quantum, on innovation policies, and many other things. So today, I want to focus on this population. Yeah, on the population of policymakers. So in the morning we saw, you had presentations saying how, you can communicate about quantum with art, and now, I see use very much also the use of cartoons and so on. So, but I really agree with Mira that policymakers do not need to go in the nitty-gritty of the explanation of what quantum is, actually. They need to know what are the implications of quantum for the economy, for industry, and what kind of policy issues are emerging, and so that they can do something about it. Basically, what's the issue for policymakers? It was said by other speakers. So first of all, the mystery. Also, Professor Kim mentioned that. There is a mystery around quantum superposition. Is it something intuitive, entanglement? Personally, I don't understand it. I probably am the only one who doesn't have a quantum background in this panel. But it's this mysterious mystery around quantum that attracts people, including policymakers. They say, oh, it sounds really cool, this quantum. And what can it actually do to the economy, to society? And the hype that Mira and others have mentioned, this can really be misleading. It's the hype that emerges in industry. So there are lots of vendors with technologies that are not mature enough, and they put out information that is misleading and so on. It misleads researchers. So if researchers have pressures that they should do research in certain fields because they can secure more funding, that distorts their decision as well. So this whole hype can mislead policymakers. They can, force them or incentivize them to go and make policy decision, funding decision, maybe in areas they shouldn't, or set some kind of unrealistic targets. So this is really a problem for the policymaking community. So it's important because ineffective science communication undermines the credibility of scientific experts, of scientific institutions, policymakers if they make wrong choices. It can also damage nascent industries in a way. So there is this incentive of being hype so that you can attract talent, investments, and so on. But you can also damage the industries that are not making the right choices. So at the OECD, we work on science policy. And already in 2023, we have put out some principle of communicating science responsibly. This is any science. It's not particular quantum science. So the issue of communicating science properly and responsibly has always been there. But obviously, there's been a transition from the way communication was made through traditional intermediaries, through newspapers, scientific publication, and so on, and the use of digital tools like online and social media. Now everybody can communicate around science, and how do we know if these communicators are trusted or not? There are new communication actors. There is a lot of misinformation going around due to the possibility of using these digital tools that reach the audience very fast before you can actually check the information. The information is already out there. And so there are lots of also dissenting scientific views. We heard some examples, and polarization of discussions around science. So this is all has to do with communicating science responsibly. So we have actually developed some principles at the OECD for responsible science and communication. They can be grouped around those 6 points. Transparency, you need to be able to give access. This is for researchers in particular. You need to be able to give access to data, and also the methods, how you're doing things. Things need to be replicable. You need to be inclusive, so give up opportunity, reach out to diverse communities, and give the opportunity to everybody to access to the scientific communication, so the science you're doing. You need to have integrity, so respect some ethical and professional standards in science and communication. This goes without saying. Being accountable, so when science is communicated, who is responsible for that communication? You know, is it you who has produced the science? Is the institution? Is someone else on your behalf? Is a science commentator that is reporting what has been done? Freedom and autonomy, obviously, when you're doing science and you're communicating about it, you have to be careful not to have external pressure and interference. And so there are some codes of conduct that researchers have. And this is timeless because these were produced during 2023, so just after COVID. And there's, you know, we studied a lot how you have to communicate in times of crisis. You need to be very fast to avoid issues, problems, misconceptions. But at the same time, you need to come up with information that is reliable, accurate enough. So there is a trade-off there. So I'm not too worried about the future. I'm talking about the policymakers of today. I think we have heard today that there is a big role in communicating and teaching about quantum in education. Today, quantum is being taught through cartoons. Quantum is being taught without any mathematical requirements, so that Quantum in Picture book is the book I think Chara was referring to, so teaching kids of high school without, so that even if they don't have any training in mathematics, it's possible. And then there is a lot in university, there is a lot of science communication courses and so on. So not to worry about the future, but now, today, how we actually transmit the message about science and technology for any emerging technologies. But now, today, we're talking about quantum is very important. Thank you.